In this video, we're going to talk about the dot product. And one thing that we're going to talk about is that we can easily calculate the vector angle between vectors using their components. The dot product is a key part of this calculation. So the first thing we'll talk about is the angle between two vectors. If we are given two vectors, say vector u, and remember we talk about a vector with a bold lowercase letter, so vector u and vector v, we can calculate the angle theta between those vectors. So the angle theta between any two non-zero vectors, u in component form, u sub 1, sub 2, and sub 3, as well as v in component form, v sub 1, v sub 2, and v sub 3, is given by theta equals cosine inverse of u sub 1 times v sub 1 plus u sub 2 times v sub 2 plus u sub 3 times v sub 3. And in that argument of cosine inverse, that's my numerator. My denominator is the magnitude of u times the magnitude of v. And remember, when we are finding the magnitude of a vector, we are squaring and summing the components, and then we take the square root. So we have a calculation for each of these. The numerator, this long product and sum, or sum of products, is called the dot product. The dot product, u dot v, is a scalar. So I've brought this in. The dot product, u dot v. Now this dot symbol is larger than a multiplication dot. It's a little bit more bold, and we use this with vectors. U dot v. If we have a vector u in component form, v in component form, u dot v means we're going to multiply our I components, our j components, and our k components, or x, y, and z. So u sub 1 times v sub 1 plus u sub 2 times v sub 2 plus u sub 3 times v sub 3. So you see this right here is the same as what we have written up above. Really, this is the same as writing u dot v. So more or less, we can take that equation over there and say we can calculate theta, the angle between two vectors, by saying cosine inverse, and my argument, the numerator, is u as a vector, bold, dot, bold, v, over the magnitude of u times the magnitude of v. And we can always rearrange equations. Sometimes you may see it written cosine theta equals u dot v over the magnitude of u times the magnitude of v. So again, when we write these vectors, when we're referring to them as a vector, they are in bold face. So let's do an example and talk a little bit about finding a dot product. Here, we're going to find the dot product of two vectors u and v. U is 1/2 I plus 3j plus k, and v is 4i minus j plus 2k. So we could rewrite each of these vectors. I could say u and write that in component form. U is equal to 1/2, 3, and 1. And v is equal to 4, -1, and +2. So these two notations mean the same thing. They're interchangeable. If we are asked to calculate u dot v, what that means we do is we're going to multiply the components, the corresponding components, I should say, and then we'll add up those three products. So I have 1/2 times 4 plus 3 times -1 plus 1 times 2. Simplifying that, I get 2 minus 3 plus 2, which is 4. Take away 3, or positive 1. So my dot product is the scalar value positive 1. That's how we find a dot product. And again, the dot product is useful because it's in the formula for the angle between two vectors. Now I'm going to prove or derive theorem 1, which was the angle between two vectors. So here, we're going to use this triangle created by the sum, or actually this is the difference of two vectors, and this resultant W is equal to U minus V. So we're going to use the law of cosines. And just to refresh your memory, if we had a triangle A, B, and C, and we were trying to find, say, angle C, the law of cosines would say C squared equals A squared plus B squared minus 2AB times the cosine of that angle, capital C. All right, so that's my law of cosines. We learned that in trig, and we're going to apply that to this triangle that we have here, U and V, and the resultant of the difference of those vectors, U minus V. So W, the magnitude of W squared, equals the magnitude of U squared plus the magnitude of V squared minus 2 of the magnitude of U times the magnitude of V times cosine of theta. I'm going to rearrange this a little bit and move this term over to the left and the W squared over to the right. So that gives me 2 magnitude of U times the magnitude of V cosine theta. When it moved to the left, it became positive. Magnitude of U squared plus the magnitude of V squared minus, since I'm moving that to the right, it would subtract the magnitude of W squared. And since W is U minus V, then if we wanted to write W in component form, W would be U1 minus V1, U2 minus V2, and U3 minus V3. So let's do some intermediate calculations. The magnitude of U is the square root of the sum of the squares of the components. So we have U sub 1 squared plus U sub 2 squared plus U sub 3 squared. And since I have the magnitude of U squared, I'm going to square the left, square the right, and this simplifies to the magnitude of U squared equals U sub 1 squared plus U sub 2 squared plus U sub 3 squared. I can do the same for V. So the magnitude of V is the square root of each of the sum of each of the components squared. So V sub 1 squared plus V sub 2 squared plus V sub 3 squared. And again, because I have the magnitude of V squared, I'm going to develop that by squaring the left and the right. And of course, the square root and the square cancel. So the magnitude of the vector V squared is V sub 1 squared plus V sub 2 squared plus V sub 3 squared. And we also have the magnitude of W squared. Now the magnitude of W squared is going to be a little bit messier to calculate because these components are a difference. They're a little bit messier to begin with. So if we were to calculate the magnitude of W, that would be the square root of U sub 1 minus V sub 1 squared plus U sub 2 minus V sub 2 squared plus u sub 3 minus v sub 3 squared. Again, wanting to calculate that magnitude squared, I can square the left, square the right, and I'll see that this square and the square root will cancel, so I just need to calculate each of these products or FOIL each of these. So the magnitude of w squared gives me u sub 1 squared minus 2 u sub 1 v sub 1 plus v sub 1 squared plus u sub 2 squared minus 2 u sub 2 v sub 2 plus v sub 2 squared. And I'm running out of space for squaring this, so I'm just going to write this down on one line. We would get u sub 3 squared minus 2 u sub 3 v sub 3 plus v sub 3 squared. So now I know what the magnitude of u squared is, the magnitude of v squared, and the magnitude of w squared. Magnitude of u, magnitude of v, magnitude of w. So I'm going to plug these in. I'm going to bring this down, this whole equation. So I'm going to rewrite that down here, and we're going to plug some values in. So I have 2 magnitude of u, magnitude of v, cosine theta. We said that was equal to the magnitude of u squared plus the magnitude of v squared minus the magnitude of vector w squared. So my cosine, my left side of the equation, is equal to u sub 1 squared plus u sub 2 squared plus u sub 3 squared, because that is my magnitude of u squared, plus my magnitude of v squared, we said was v sub 1 squared plus v sub 2 squared plus v sub 3 squared. And then we have minus, and when we are subtracting, we need to make sure we have that distributive factor included. So I've got minus the magnitude of vector w squared. U sub 1 squared minus 2 u sub 1 v sub 1 plus v sub 1 squared plus u sub 2 squared minus 2 u sub 2 v sub 2 plus v sub 2 squared. And then again, we've got plus u sub 3 squared minus 2 u sub 3 v sub 3 plus v sub 3 squared. So this minus is going to distribute to all of these terms and change signs. And what we'll notice is we have u sub 1 squared minus u sub 1 squared. Cancels. U sub 2 squared minus u sub 2 squared. U sub 3 squared minus u sub 3 squared. V sub 1 squared minus v sub 1. V sub 2 minus v sub 2. And the v sub 3 squared minus the v sub 3 squared. So what we are left with is 2 times the magnitude of u times the magnitude of v times cosine of theta. What we're left with is 1, 2, 3 terms. And of course, we're subtracting all 3 of those terms, so those are going to become positive. So I have 2 u sub 1 v sub 1 plus 2 u sub 2 v sub 2 plus 2 u sub 3 v sub 3. At this point, we can factor a 2 out on the right, and we have a 2 as a factor out in front on the left, so we can cancel that 2. I've got the magnitude of u times the magnitude of v times cosine theta equals u sub 1 v sub 1 plus u sub 2 v sub 2 plus u sub 3 v sub 3. And so again, I had a times 2 in front of every term, so I was able to divide those out. Now, what we should notice is this is the definition of a dot product. So, magnitude of u, magnitude of v, cosine theta equals u dot v. Or rather, cosine theta equals u dot v divided by the magnitude of both u times v, or the angle theta between those two vectors u and v equals cosine inverse of the argument u dot v divided by the product of the magnitude of u times the magnitude of v. Therefore, this is our definition. We derived the formula for the angle between two vectors. And if we want, we can also say that the dot product u dot v is equal to the magnitude of u times the magnitude of v times cosine theta. This is what we had up on this line. So that sometimes is useful as well. So in this video, we talked about what the dot product is, how to calculate it, and then also we talked about the theorem for the angle between two vectors. We derived that theorem. In the following video, we're going to do an example, maybe two examples, where we use this formula.